Hello everybody. We're going to review for the Unit 2 test starting now. What you have here is pretty much the test. There's only 2 questions that are different between this paper and the test itself. So the non-calculator part goes all the way up to problem number 10. All right, and that's exactly what you're going to see. It's not that many questions, but some of the questions have a lot of parts. The very first question on the test is also multiple choice. There are 17 questions on the test. There are 19 questions on this, so like I said, there's only 2 questions that are different. So what we're looking for here is negative, and this is a power of 1, this is a power of 2, this is a power of 1. So we're looking at negative x to the 4th. So we need both ends to go down. So with both ends going down, that eliminates A and B right away. So now we have both ends going down, and we can narrow this down based on the x-intercepts. So we have an x-intercept at -3, -1, and +2. All right, so -3. This is -3. This is -1. This is +2. Well, this one has +1 and +3. So without even really looking at it too closely, you can tell that it's C. Now, if you needed to go into some more details, you can tell that it bounces. There's a bounce at -1 based on the fact that there's a power of 2. So that would also sort of help you narrow it down. At -1, we need a bounce. So end behavior, x-intercepts, and multiplicity at your x-intercept is all you'll need to be able to determine that. Now, on the test, you have all of these exact same questions, except for number 5. I'm sorry, not number 5, number 2. So I will not ask you about the degree. But the degree, that's a smart question to go through. You want to think about it, but I'm not going to ask you for that question. So this degree, this is a 1, and then 2, and then 3. 1 plus 2 plus 3. So this is x to the 6th. X to the 6th, obviously even and positive. You know that both ends are going to go up. That's helpful. I'm just going to do that right now. There is an end behavior question. All of these questions are on there, with the exception number 2. So this is going to be, it's kind of small in here. X goes to infinity, y is going to infinity. X is going to -infinity, y is going to infinity. So we know both ends are up. Maximum number of turning points would be 1 less than that. So this would be a 5. And I know a lot of you go through and think, well, I have to show 5 turning points. You don't, all right? So that's just an easy question, which is why I keep asking you that question. You don't really need to pay attention to it when drawing your graph. X-intercept means to make all the, or find the y-intercept, that means to make all the x's 0. So we have 0 times 0 minus 2 squared times 0 plus 1 to the 3rd. So 0 times 4 times 1 is still 0. So our y-intercept is at the point 0, 0. Oh, it's too many zeros. Find the zeros. These are your x-intercepts. That is to say, set each factor equal to 0. So we get x equals 0. It's already on my graph. We get x equals 2. It's going to bounce there. We also get x equals -1. It's going to slide there. So if we throw in the end behavior, this end goes up. That end goes up. Our y-intercept is right already there. Our graph, we do have some mysteries about our graph. We know it's going to bounce at +2. So this is a bounce right here, but we don't know how high. All right, so then it's going to come through, and it's going to go right through 0. And then when it comes back up through right here, it's going to slide. And I know that the slide is hard to draw. Another way that you could draw this is to count by like 1/2 going left and right. So let me show you a different way you can draw this graph. That's correct. The way that graph is correct. But if you don't like that, let's do it different. So I'm going to, this is still 0. Here's 1. Here's 2. I'm going to spread this out a little bit, and then here's negative 1. My ends are still going up. When it hits 2, it's going to bounce. I don't know how high it's going to go. It's going to go straight through 0. And when it comes up through 1, it's going to slide. So you may find it easier to spread it out a little bit more left to right. It's up to you. It's the same graph, but it is a little bit easier to draw. Eight, 9, 10, all on the non-calculator part. First thing you better do is factor this thing, because if you have a hole in the graph, you've got to get rid of it first. So make sure you factor this before you do anything. Multiply to get to 5, add to get to 4. I always say add, but you know I mean subtract as well. I got distracted, sorry, by the bottom because it was so easy. So multiply to get to 5, there's only one way to do that. That's 5 times 1. And then if I want it to be a negative 5 on the outside, that means I need a positive times a negative. And when I add, I want to be a positive 4. So 5 minus 1. Now you can see right here, gone. We do have a hole. So x plus 5 is equal to 0. We have a hole at x equals negative 5. Make sure you factor it first. Horizontal asymptote. Now if we take a look at our graph, our function rather, get rid of all that, we have basically y equals x over x. We don't care about the number, so this is 1 over 1, so we get y equals 1 because the degree matches, so you use the lead coefficient. For number 9, the vertical asymptote, you take the denominator, set the denominator equal to 0, so we get x equals 5. Your hole and your asymptote should never match. If they do, you have a mistake. You can't have a hole and an asymptote at the same spot. And then we begin the calculator part. The second and the last difference between this and the actual test is this section right here. On the test, there is only 2 factoring problems. I've given you 3 just for practice. It says find all the zeros. That's a hint to you. Probably some of them are imaginary, which means your calculator is useless. So be careful. It says zeros. It doesn't say x-intercepts. If it says x-intercepts, then you know your calculator is probably helpful. This says zeros. So we're going to factor this. Difference of 2 squares here. X squared minus 4 and x squared plus 4. Set that equal to 0. Then each factor gets set equal to 0. Keep track of your signs because signs matter. Here we get x squared equals 4. When you take the square root of 4, you get plus or minus a regular 2. Over here, when we subtract 4, now we're going to take the square root of a negative 4, and that's plus or minus 2i. So you make sure you need all of those, because there should be 4 answers, matches the degree. Number 12, we got 4 terms. We're going to split it up. First 2 have x squared in common. Leaves you with 2x minus 1. Remember, you're dividing. X squared divided by x squared is a 1. The next 2 have a positive 4 in common. 2x minus 1 again. This equals 0 by ran out of space. So 2x minus 1, that's your common factor. That stays in parentheses. Then left to right, x squared plus 4. Set each factor equal to 0. So we get 2x equals 1 and x equals 1/2. Over here we get x squared equals negative 4. Square root, always the plus or minus. We're taking the square root of something negative, so it's an I. The square root of 4 plus or minus 2i. Number 13, nothing in common. In order to make it x to the 4th, we need x squared times x squared. 14 is 7 times 2, and then negative 7 plus 2 is a negative 5. So x squared plus 2 equals 0. X squared equals negative 2. Taking the square root of that. I took the square root, so I get plus or minus. It's negative, so the I comes out. Don't know the square root of 2. So it stays like that. X squared minus 7 equals 0. We get x squared equals 7. Square root. Don't know the square root of that. Plus or minus radical 7. Oh, degree 4. So we should have 4 factors. Roots of 5i and negative 1i, which means we also need a minus 5i and a positive 1i. There's your 4 factors. X minus 5i, x plus 5i, x plus I, x minus I. When you multiply I times I times I, that's I squared, and I squared is equal to negative 1. So when you use multiplication on this, we're going to get x squared. Now I'm just going to multiply negative 5i, because you know the inside and the outside cancel. Negative times a positive is a negative. 5 times 5 is 25. I squared. We're going to take that out. So this becomes a negative 1. This is multiplying. 25 times negative 1. So we have x squared plus 25. I'm going to do the same thing with this piece. So when you multiply the fronts together, you get x squared. Inside and outside cancels. Positive times a negative is negative. I times I is I squared. This becomes a negative 1. So we're left with x squared plus 1. No more imaginaries. Now we're going to multiply that together. X squared times 1. So we get x to the 4th plus x squared. Then we're going to take 25 times x squared, 25 times 1. Plus 25x squared plus 25. Combining like terms, we get x to the 4th plus 26x squared, remember this is a 1, plus 25. Two problems like 15 and 16 on the test. So you will have, just like you see here, one that's a fraction and one that is not a fraction. You do them differently. They both use number lines, but the process is just a little bit different. Number 15, we want to get it set equal to 0, which means we got to move these pieces over. X to the 3rd minus x squared minus 4x plus 4 equals 0. 4 terms, split it up. They have an x squared in common, x minus 1. This starts with a negative. It has to come out. Negative 4. Negative divided by a negative is a positive. Positive 4 divided by negative 4 is a negative 1. Common factors coming out. And we're left with x squared minus 4. When you solve this, you get x equals 1. Here you get x squared equals 4, so we get x equals plus or minus 2. Those 3 numbers are going to go on the number line, and all 3 numbers are going to use the original sign, which has no line under it. So negative 2, 1, 2. Pick a section to test. I'm going to test this section right here. These are all open circle. I mentioned it, but I forgot to put it on there. So x equals 0 is going right back into my original. 0 minus 0, is that greater than 0 minus 4? So 0 minus 0, is that greater than 0 minus 4? So is 0 greater than negative 4? Yes, it is. So this is yes, no, no, yes. So the answer in interval notation here is negative 2 to 1. And from 2 to infinity. Now for 16, this is a little bit different. The numerator is allowed to equal 0. 2x to the 3rd minus 4x equals 0. The denominator is not allowed to equal 0. First, we want to see if we have any common factors, though. I was going to factor these separately, but you should factor them one on top of the other and keep track. If you have a common factor, it has to come out. These have a 2x in common, and we're left with x squared minus 1. How about x squared minus 2? Sorry. And the denominator, they have a x squared in common. Ooh, we do have a common factor. And that leaves you with 3x plus 4. So we have a common factor in that this x on the top cancels with one of these x's on the bottom. So we got rid of that whole. So that factor is gone completely. So 2 equals 0, x squared minus 2 equals 0. Well, 2 equals 0 makes no sense, so that's gone. Here we get x squared equals 2, and x equals plus or minus radical 2. Well, you'll have a calculator, so you'll know what that number is, so you can graph it. And over here, the denominator not allowed to equal 0. 3x plus 4, not allowed to equal 0. So we get x is not allowed to equal negative 4/3. So on the number line, we will have negative radical 2, negative 4/3, open, because it's not allowed to equal. 0, open, not allowed to equal. And then positive radical 2. Now the 2 that has no circle on them, we go back to the original. The original has a line under it, so these will be colored in. Now we're going to pick something to test this. I'm going to test 1. I feel like that might be the easiest. And 1 is right here. I'm going to put that back into the top. So 2 times 1/3, or 2 times 1 to the third, minus 4 times 1. The bottom is 3 times 1 plus 4 times 1. Is this greater than or equal to 0? Negative 2 over 7 greater than or equal to 0. Well, no, it's not. All right, so no, yes, yes, no, yes. And now we can write the answer, I hope. It's a big answer. So the answer would be negative infinity to negative radical 2. Starts up again at negative 4/3 to 0, and then it goes from radical 2 with the squared bracket to infinity. Now you will have your calculator here, but I'm expecting that your asymptotes will be drawn perfectly, not some sort of random sketch from the calculator. So this, we're doing the horizontal asymptote. There is x to the 0 on top, and there is x squared on the bottom. The higher degree is on the bottom, so our horizontal asymptote is y equals 0. Vertical asymptote, set the denominator equal to 0. So we get x equals negative 5. I'll put that on the graph. Can't see it too well, so I'm going to change colors here. And then the other one, of course, x minus 1 equals 0, so we get x equals 1. I did not put my horizontal asymptote on the graph yet. I'm waiting to look at the calculator. When you type this in the calculator, if you can't make it a fraction, you're going to have to add parentheses around the whole thing. And so when you do that, you'll see that the asymptote is not ignored inside there. And so we go to draw this. This is like a flatter kind of U. And then down here. Down here. Now I was not asked for the x and y intercepts, so I did not find them. It's not asked for it. Just look at the calculator, draw the graph. So now we have to kind of answer this question. As x approaches negative 5, well, this is where x equals negative 5. We are approaching negative 5 from the negative side. That's this way. I'm coming at this thing from negative infinity, and it's headed down. So the answer is that it's approaching negative infinity. Last question on the test is to write the equation of a rational function. So you know you're going to have a fraction. This looks like x equals 3 maybe. That's your horizontal asymptote. So that looks like, I'm sorry, y equals 3, my fault. And so that means it moved up 3. So that's going to be my stick out. And then I need the vertical asymptote, which is a little bit harder to see, but I don't think it's at 0. It's definitely at x equals -1. Your vertical asymptote goes in the denominator. All right, so if the answer is x equals -1, the factor is x plus 1. Now, also, your parent graph should be upper right and lower left, but it's not. It's switched. It's reflected, so I need a negative sign in the numerator. Now, don't add any letters. Just put the 1 in the top, just to keep it simple. Make this as simple as possible. Also, you have your calculator. I would suggest whatever you write down, you put in the calculator and see if it works. It's worth it. There's not very many questions on the test, so each one is worth quite a bit of points. It's worth it for you to take your time as you go through these and check your answers like a graph. That's an easy one to check. Just type it in and see if you did it right. Good luck on the test. Let me know if I can help you. I'll be available during E&I.